Hey everyone, welcome to another video. Today we're going to look at how to graph quadratics. Um, and I guess the first thing to say is that there's heaps of different sort of information, different things you can use, and it's about again being efficient and knowing what's in sort of the bare minimum that you need to be able to do it. And so you can do all these calculations, you can complete the square, and you can check the discriminant, and you can find the axis symmetry. There's all these things you can do, but it's about, well, what do I actually need to do to be able to sketch this thing quickly and easily. So you don't need to do everything because I'm going to throw a lot of things at you today. Okay. So firstly, it sort of really depends on the form that you're given. So there's the general form there. Okay. So if ax squared plus bx plus c, if that's the form of the quadratic you're given, there's a bunch of things you can do there. If you're given the quadratic in turning point form, so that's the turning point form there, then it's very simple to sketch the quadratic there. Or if you're given it in factorized form like that, then that's also very easy. Most of the time you're given it in general form because they want you to do a little bit of work to show that you know how to do various things. Okay, and so both of my examples today I'm going to be giving you to do it in general form. And so there's my two examples that I'm going to be doing today, both in general form, because I'm going to sort of change them into factorized form or turning point form so that you can sort of see how that works. Because turning point form, really easy. You'll see what happens there. Okay, so let's just firstly, we'll go. I'll go to turning point form first because just to quickly do it. So if you've got turning point form, then you've got A, you've got H, and you've got K, and they tell you certain things. So firstly, in turning point form, if you've got it like that, then the turning point will be H, K. Okay, so whatever the H is, that'll be the X coordinate of the turning point, and whatever K is will be the Y value of the turning point. Okay, so that's really easy. You just read straight off there. Just one thing to note is that it's X minus K, minus H there, so be careful, and that's plus K there. So they're two things you have to be careful of. So, and you'll see that in my examples today. Just got to read off those solutions from there. Also, the value of the value of A out the front. If A is positive, then you're going to get a positive gradient. So you can see that's like a smile. So A is positive, you're going to get a positive parabola looking like that, a smiley face, some students say. If A is negative, then you get this negative upside down face. You're going to get like a maximum turning point there. So if A is less than, so that gives you a bit of an idea of the shape that you're looking for as well. So that's turning point form. The other thing, if you're in turning point form, is if you find the x and y intercepts, that's usually enough because you'll have, if you're doing your graph, then your turning point's there and it goes like that. And if you can find your intercept there and there and there, etc., then that gives you all the sort of the points that you need to be able to do an accurate graph. Okay, so that's in turning point form. If you've got it in factorized form, like we have there, just remember that if it's factorized like that, then you can solve where that's equal to 0. So you can solve where that is equal to 0, and that will be equal to 0 when that is equal to 0 or when that is equal to 0. In other words, the x-intercepts will be at the points P and Q. Okay, so if you got your graph, then one of the x-intercepts will be P, and the other one will be Q. So that's where the graph's going to go through. You can have a look at, again, you can have a look at the value of A. If it's positive, you're going to get a quadratic looks like that. If it's negative, you're going to have a quadratic that looks like that. And that gives you a bit of an idea of whether it looks like that or whether it looks like that. And the other thing that you can do is to find the y-intercepts as well. I didn't put that on. I'll just chuck that on the list. Also, you can find, sorry, a bit messy, find the y-intercept because that will sort of help you as well. And often students use that y-intercept to help tell them whether it's upside down or right way up, maximum or minimum as well. Okay, so that's what you do if you're in factorized form. And again, that's actually really simple. Doesn't take a lot of working out if it's already in factorized form. But if it's not in either of those two forms, then you've got a bit of work to do. Okay, so it's a little bit trickier. One of the things you can do is complete the square, because if you complete the square, that turns that into turning point form. Okay, and then from there, you're fine. You just sketch the turning point. You do the same thing as if you had it already in turning point. if you're not very good at completing the square, it does make your life a bit trickier with doing it, but not impossible to still sketch these things. You can also find the axis of symmetry, and what that is it's the axis of symmetry is just where the quadratic is symmetrical. Okay, so if you had a quadratic like that, the axis of symmetry is like the line down the middle that tells you that it's the same on both sides, so it's symmetrical. If that's like the mirror image from one side to the other, okay. And the equation of that line is x equals negative b over 2a, okay. And that helps you to sort of get an idea of at least that. And once you've got that axis of symmetry, that actually gives you the x value of the turning point there. So if your turning point is xy, then that x value is that there, okay? So that tells you one thing. So you can find the axis of symmetry. Once you've found that, you can substitute that x value into the equation and you can find the y value. And so you can get the turning point from there. You could also try to factorize it. And that will get, if you factorize it, so this page is getting a little bit messy, but I hope it sort of, helps you to sort of understand. If you factorize it, that gets you into factorized form, and then you can just do all the things that we talked about down there. Again, if you're not good at factorizing, you can still do these things without doing it, but it just makes your life a bit trickier. You can also check the determinant. Remember, if the determinant is greater than 0, you get 2 x-intercepts. If it's equal to 0, you get 1 x-intercept, so it's touching the x-axis. If it's less than 0, then you'll get no x-intercepts, so it doesn't cross the x-axis at all. And again, you can find the y-intercept. Now, I've made an absolute mess of that page, but hopefully that sort of makes sense as to all of your options when you're sketching a quadratic. Let's actually do a couple, all right? So let's sketch this guy here. Y equals 2x squared minus 8x minus 24. So let's go. I'll do a bunch of things and I'll just sort of talk through different options here. So I can immediately see that there's a common factor of 2 in all of those things. And so it looks to me like this would actually be easy to factorize. So let's do this. So if I take out 2 out the front, x squared minus 4x minus 12. If I take that and have a quick look at it, is that going to be easy to factorize? Factors of 12 are 4 and 3. Can I make 4x out of 4 and 3? No. I could also try 6 and 2. I think I can. So I'll take out 2 and I'm going to do double brackets. I'm going to put x there. Just going to try this. 6 and 2. How do I make negative 4 out of 6 and 2? I go minus 6 plus 2, and negative positive makes negative 12, so that is correct. So I've now put that into factorized form. Okay, so now that I've got that, life is actually pretty easy, and you'll see, and you'll go quicker than I will because I'll sort of show you. So let's firstly find out what the x-intercepts are here, right? The x-intercepts are when y equals 0. In other words, we solve 2x minus 6, x plus 2 equals 0. We're solving that. And remember, the null factor law says that if any two things are multiplied together and we get 0, then one of them must be 0, or both of them must, or is equal to 0. So if x minus 6 is equal to 0, then we get x equals 6. Or if x plus 2 is equal to 0, then we get x is equal to negative 2. So there are my two x-intercepts. Let me now find my y-intercept. That happens when x is equal to 0. If I sub in x equal to 0 there, I get y equals 2 times 0 squared. I hate doing all this, but I'm just showing you that. I'm just substituting in x equals 0 minus 24. So that is equal to negative 24. So my y-intercept is negative 24. Okay, so there's a few things. What else did I recommend up there? Factorized form. We could find, the axis of symmetry. Let's just do that because I'll show you that quickly if you couldn't factorize it. So if you couldn't factorize it, I'll just come in here, add some stuff here. Axis of symmetry, not the axis of evil. Axis of symmetry will be when x equals negative b on 2a. And that's equal to negative b is negative 8 over 2a is 2 times 2, which is positive 8 over 4, which is 2. So the x value of 2. And you'll see when we start sketching it, the axis of symmetry. So what that means, when x equals 2, that's the line that goes down where the parabola will be the same on both sides of that. Okay, so that's the axis of symmetry. Anything else we want to do? I'm not going to complete the square with this one. I'll do that secondly. Let's just check the determinant. Okay, and you'll see that, determinant is equal to b squared minus 4ac. And what do we got there? So b squared is negative 8 squared minus 4, a is 2, c is negative 24. Oh, it's going to be big. Ugh, this looks a bit gross. Anyway, I'm not going to figure it out. Negative 8 squared is 64. And we've got, can't even read my own writing, that's 2. Anyway, it's a negative times a negative, so it's going to be plus 4 times 2 times 24. In other words, that's a massive number. I don't care what it's equal to. It's just we know that it's greater than 0. Therefore, there's going to be 2 x-intercepts, okay? And we already know what our x-intercepts are, but that's just how you would use it. If you weren't able to factorize, you could use the discriminant to go, okay, there's 2 x-intercepts. The other thing we can look at, I'm throwing a bunch of different information at you here, and you can pick and choose what you need to do on any different question. Here, a is equal to 2. So the number that's in front of x squared is equal to 2. And so I know that the graph is going to be a minimum turning point. It's going to be a smiley face, a positive a is greater than 0. So you're going to get this positive smiley face sitting up like that. Okay. And so that's all I need to do. And so what I'm going to do now, I'll also show you the turning point. Okay. I'm going to run out of space. I haven't allowed much because I've sort of done more than I'd normally do. Let me just, I'll get rid of that last thing actually. Obvious. Okay. Last thing is we'll look at is because we know that the axis of symmetry x is equal to 2. That means that the turning point will be when x equals 2. Okay. So coming from the axis of symmetry is when x is equal to 2. I can just substitute x equals 2 into that, and that will tell me my turning point. Okay. Without having to try to complete the square. I'm trying to show you some shortcuts if you don't like completing the square, which I know some of you don't. And so therefore, y is equal to 2 squared. I'm just substituting in x equals 2 minus 8 times 2 minus 24. And so that's equal to 4 times 2, that's 8, take away 16, take away 24. 8 take away 16 is negative 8, negative 8 take away 24 is negative 32. Okay, so I'm just going to do a quick sketch of what this thing looks like. Let's put all that information on there. So firstly, my x-intercepts are 6, so 6 and negative 2, negative 2. My y-intercept is negative 24. I know it's not to scale, but you'll get the sort of the picture. Negative 24 down here. The axis of symmetry is x equals 2, so I'm at 2. Just going to do a dotted line down here. That's my axis of symmetry there at 2. I'll just put my equation for that, x equals 2. If you're asked to sketch the axis of symmetry on the graph, then do it, but you don't need to otherwise. I've put that on there, I've put that on there. I know there's 2 x-intercepts, and my turning point is when x equals 2 and y equals negative. So it's down here somewhere, my turning point. I'm just going to label it after I've drawn the graph. So we know it's a smiley face, and so the graph, I'll do it in green, comes down, it's got minimum there, and it comes up like that. And I'll just label my turning point now that that's out of the way. And so when x equals 2, y equals negative 32 is my turning point. I just need to label my graph, and so I'll label y equals 2x squared minus 8x minus 24. And so there is my sketch of my graph. That's over the top. You'd never do that much work, but you need to choose what information do you need to be able to accurately sketch it. And so normally I would attempt to factorize it to find my x-intercepts, maybe find the y-intercept, and I'd probably quickly find the turning point as well, either by completing the square or by just chucking it into the turning point. The other thing I didn't say, sorry, and I should mention this, is that if you know the x-intercept was negative 2 and 6, we know that the axis of symmetry is exactly halfway between those two values. That is always true. Always halfway between the two x-intercepts. And so, so what's halfway in between negative 2 and positive 6? Well, the distance is 8 between those two, and so half of 8 is 4, so I move 4 between there and there, and there and there, and so the middle is 2. And so that's another way you can find the axis of symmetry without sort of doing any work. But that's essentially what negative b over 2a is doing anyway. Okay, hope that all makes sense. That's how that. Let's go on to another one, and let's do one where we complete the square now. So I want to just make sure that you can see that as well. So I'm going to take a bit quicker here because I want to show you that if you can complete the square, if you're good with factorization, then life is good. So to complete the square here, I need to take the -2 out the front. And so I'm going to go x squared. I'm going to take out -2 from positive 4x. I get -2x. Okay, and I'm going to close the bracket here and just leave my -5 there. Okay, so I'm about to complete the square. I haven't changed anything yet. Everything is as is. I've just taken that -2 out the front, and that -5 is sitting there at the moment. Now I'm going to complete the square of the middle. What do I need to do to complete the square of x squared minus 2x? I need to halve -2, -1, and then square -1 gives me +1. So that will complete the square. I'm not allowed to just add +1 from nowhere, and so I also need to -1 there. Okay, so that's there. I haven't changed anything there. It's still equal to this. Okay, so let's do a little bit more work. So now I've got x minus 1 squared. That is that stuff going down into that stuff there. Okay, so that I've created that perfect square, and then I've also got that -1 left over, and also this -5 still sitting out the back. Okay, hopefully that makes sense. Go watch the complete the square video if not. And so that's -2. And now I'm going to expand. I'm going to time this -2 by everything. So that's -1 squared. So I times that. And then I also am going to times that -2 by that -1 to expand. What I'm doing is I'm expanding everything out here. So that -2 times that -1 is +2. And I've still got my -5 out there. And so just to finish it off, what it is equal to -2x minus 1 squared. 2 minus 5 is -3. Okay, and so that is now in turning point form. What have I got? Well, I'll come down here and do my sketch down here. So what that means is the turning point is going to be at 1, -3. Okay, so 1, -3. So I'll do it in red. So at 1, -3. That's going to make it, I'll just squeeze it in a little bit more than that because it's not going to be great. 1, -3. So my turning point is going to be at that point there. That -2 out the front, that A, is going to mean it's a grumpy face. It's a negative. It's a horrible, it's not happy. And so it's going to be upside down like that. And so I know it's going to look something like this. Okay. But to get a more accurate picture, let's also find that y-intercept. So the y-intercept when x is equal to 0, if we sub x equal to 0 into there, then y is equal to -5. Okay, and it's really easy because that just goes, and you're just left with -5. Okay, so when x is equal to 0, so at -5 down here will be my y-intercept, and that's enough for me to do a graph here. And so I'm going to put it on, so it comes up like that, goes down like that. And so that's my graph of y equals -2x squared plus 4x. Very messy, sorry. And that's my graph. I've labeled my y-intercept. I should label my turning point there as well. 1, -3. Okay. If we found the determinant for that, I bet you the determinant will be less than 0. How do I know that? Because it doesn't have any x-intercepts. And so it's impossible to find those x-intercepts because it doesn't cross them. So hopefully that makes sense on how to sketch quadratics. We'll see you in the next video.